let's take a look at this inequality that involves e to the x. And it's actually going to involve u-substitution as well, which we'll see in just a minute. But before we go to solve this, let's talk about where it's dne, where it does not exist. And really, the nice thing about this problem, this is the easiest part of the problem, is that think about e to the x. E to the x is defined for all real values of x. And so because of that, there's no spot where this function does not exist. There's no x in the denominator, and because of that, the function is continuous for all real values. Now we need to figure out where it's equal to 0, because from there we can figure out where it's positive or greater than 0, right? Because what we're really ultimately trying to figure out is where is f of x greater than 0? Well, in order to do that, you first got to figure out where it equals 0, because that's where it changes, or it may possibly change. It doesn't always change. In this problem, it is going to change. But depending on the problem, it might not always change at a 0, but a lot of times it does. Okay, so we go ahead and we set this equal to 0. Well, the first thing I'm going to do is I'm going to add 2 to both sides. And I'm also going to multiply by 3. Okay, because that's going to get, if I add 2 to both sides and I multiply by 3, that's going to get rid of the denominator here. Okay, so I'm going to do 2 steps in one. I put the 2 over there. If I multiply by 3, that becomes 6. Now this denominator is gone, and we have e to the x plus 6. And I'm going to go ahead and write this over e to the x. Okay, so now is where you want to say let u equal e to the x, because you can't really solve this unless you use u. It's going to be a lot easier. So this is going to say u plus 6 over u equals 6. Now the next thing you want to do is you want to multiply everything by u, so you get rid of this denominator now. And that is going to leave me with u squared plus 6 equals 6u. Now, in order to solve this quadratic, I want to move it, or I want to get everything over to the left side. And if I do that, you can see that this is going to be a case of completing the square. So we're going to go ahead and complete the square here, and that's going to get us to at least our answer in terms of u, which then we will now go back and solve in terms of x. So first of all, if you're going to complete the square, you got a couple options, but I'm going to move this 6 back to the other side, and I'm going to say, here's my number that I'm looking for. And if I add it on this side, I got to add it on the other. Well, half of 6 is 3, or negative 3. Either way, you square it and you get positive 9. So always just divide that middle term by 2 and then square it, and that's how I know we got 9. Now, if we look at this, this is going to be u minus 3 quantity squared. Remember, it's important that if this is a minus, this has to be minus as well. And then that's equal to 3. Now remember, the whole point of completing the square is to take the square root of both sides. And when we do that, we get u minus 3 equals, oops, getting ahead of myself, u minus 3 equals plus or minus square root of 3. So u equals 3 plus or minus square root of 3. Okay, now remember, we said let u equal e to the x. So now we're going to go back up to the top here, just to save space, really, and we're going to say, well, if u equals 3 plus or minus square root of 3, then e to the x equals 3 minus square root of 3 and 3 plus square root of 3. Okay, so I'm going to now write this. And now if you take the natural log of both sides, that's how you can solve for x. Because remember, if you take the natural log here, the x goes down to the front. And then you're really saying x times natural log of e, which is equal to 1, is going to give you natural log of 3 minus square root of 3. But I'm going to do this in one step just to kind of save space here. And just know that if you have e to the x equal to something, that's the same as saying x equals the natural log of 3 minus square root of 3. And then over here, the natural log of 3 plus square root of 3. Okay, so we're almost ready to solve this in input numbers. But the inputting gets a little difficult, right? Because we got to kind of know what these numbers are about equal to in order to do this. Now, if you have a calculator, that's pretty easy. You can just go ahead and put them right in the calculator and figure out what they're equal to. If you don't have a calculator, you got to get a little bit creative, because what you're really saying, back to this part here, is you're saying, well, E is about 2.7, right? And you got 3 minus square root of 3. Well, square root of 3 is about 1.7. So really you're saying 3 minus 1.7 is 1.3. So what you're really saying is 2.7 to some power is about equal to 1.3. Well, obviously 2.7 to the first power would be 2.7. So, you know, maybe you could say 0.5. I think it's a little less than that. So let's just go with 0.4. The important thing to remember is it doesn't have to be exact. It's just got to be within the right integers, meaning like 0, as long as it's between 0 and 1, because that's what you're going to input, then you'll be fine. Okay, so going back over here, then the same thing here. We got 2.7, because what this is really saying is 2.7 to some power gives me about 3 plus square root of 3, which is 1.7. So that's going to give me about, hold on one second, that's going to give me about 4.7, okay? So now if we want to estimate this one, well, 2.7 squared gets you about 7, so let's say it's somewhere in the middle, let's say 1.4. Okay, so it's, you know, not greater than 1, but less than 2. And that's really the important part, because once you have that, you know what numbers to input. So I want to input 0 here, I want to input 1 here, and over here, I'm going to go ahead and overestimate it a little bit. I'm going to input 4, because you'll see how that's going to make it a little easier. Okay, so now we're almost done here. We got to go back up and look at this and think of the original function. Okay, so here we're looking back at the original function. Well, if I plug in e to the 0, well, that's just 1 plus 6 over e to the 0, because that's negative. Well, that's 1 plus 6 over 3. Well, that's slightly larger than 2, which means I'm going to have a positive number. Okay, so I'm going to go ahead and record that. I got a positive number here. Now let's look at inputting 1. Okay, now this one's the most difficult, I think. Well, e to the first power is about 2.7 plus 6 over 2.7, and all of that's divided by 3. Okay, so if you look here, if you think about that, right, it's like saying 2.7, right, plus 6 divided by 2.7 is about 2, and that's minus 2, and that is going to leave me with a positive number as well. Okay, so I'm going to go back down here and record that. Okay, so now I'm looking here. Actually, you know what? This is not a positive number. I made a mistake. Yeah, small mistake here. Think about this again, right? 2.7 plus about a little over 2, but it's divided by 3, and that's why you get a negative number. I had a feeling that was wrong because this should alternate. Okay, so now that gives me a negative number. Okay, now we'll do one last one, and then we'll write our final answer. The final one we want to look at is inputting 4. Well, e to the 4th is going to be pretty big, right? Because it's like saying, like, if you took 3 to the 4th, that would be about 81. So let's say it gives us 60. Regardless, 60 divided by 3 is way larger than 2, so that's going to result in a positive number. Okay, notice that's why I overestimated this, because it's easy to see that e to the 4th power is going to be pretty large. Even if I divide it by 3, this number actually is very small, but still I'm going to have a positive number. So our original problem was, where is it greater than 0? So let's record our final answer here. F of x is greater than 0 on negative infinity to natural log of 3 minus square root of 3. That's not going to get included because we don't have that included, right? And then we got natural log 3 plus square root of 3 to infinity. And now we're done with this problem. This would be our final answer right here.